Okay guys, here we are at lab 7. I'm gonna do a short demo on the first part of our ISA, including the compiler, and let's get started. So for convenience, I got my ARM compiler installed in the Linux virtual machine, and this is the result for the compile. I use GCC instead of the official ARM, but the result should be exactly the same or pretty much the same. And let's go through it. First, pre-process. The first process of which, of course, is to remove the parts that are not useful for our execution. Those comments and including the pop and push. This is not going to be helpful in for now because we don't have any like function calls, so it's also removed just to save some work for this lab. In the next lab, we have function calls, we can realize it. And the word zone, which link to LC0, and it's over here. And for the word, we got another way to do the word by replacing the LDR. If we see a mark in LDR, we're just going to direct it to a certain position in DataMan. In that way, we can do the word. So in the actual data, in actual assembly, we do not have the word zone, and just by replacing this LDR to direct it to a certain position in DataMan, and the word will be put there in advance. Okay, that's the first step of our processing, and let's continue. Now we have this, and then we have the preprocessor. The preprocessor is essentially to cope with the first the vector instructions, because it's pretty hard to realize in the actual processor. It can take extra hardware, and we can do that with compiler here just by replacing it into a bunch of LDR and add and STR and add, and so for the two components vector, replace it with STR LDR. Besides that, the preprocessor also insert loops between every command to avoid hazard, just for now, because in the processor we do not have HDU or forwarding. We have forwarding for branch, but we don't have forwarding for the hazard. So insert loops except for instruction, except for the space between instruction and branch and the compare, because if you do so, the branch forwarding, the CSPR, is not going to be there, right? You got to have the compare right next to the branch, and that's what the preprocessor do. And with that, we got a processed S. You can basically see the difference is, of course, inserted a bunch of loops. Here we're just using a random MOV as loop, and substitute this into a bunch of loads and adds and store and adds. So next part is the real compiler, the binary compiler. The binary compiler, well, to turn it all of this into binary codes, first what we do is that, yeah, we got all the lines and we have all the marks. Remove all the marks and got every and calculate their position in the instruction man. Yeah, calculate each instruction's position in the instruction man, and for labels will just be marks, just be on the next to it. For example, the main will be linked to the PC0, it is the first PC. Now we can do branch, and all of this we do have. Yeah, so this is a debug output. Over here we got all the marks, and this is just because all the marks are removed, and we just can see that this one is will be PC448 because the first one's PC0. And besides that, just to take each of it and do the manipulation to turn it into binary, and most of our binary codes follow the official ARM ISA. And for it's probably better we introduce it with a report. Yeah, let's do it with a report. So the data processing instructions, including add sub, MOV, LSL, essentially is also MOV and compare. They're all in this form, which is official ARM form for ARM32. Condition plus some opcode and register file and operand 2 for immediate and or another register. Branch is pretty special. We're going to introduce it later. And LDR, SDR, it's exactly the same as the official ISA. This one is also pretty important. The register files alias, register alias reference table, because our compiler do give non-official alias for FP. That's pretty, yeah, it's not in the official document, and then we just give it FR11 according to most everybody do. SP is just R11, and all the other aliases, SP and FP, etc. That's our register alias table. Oh, also in the debug output, all the alias will be replaced by the actual position of the register, so we can tell whether it's correct or not. Yeah, that's it. Okay, and the branch is where it's different from the official ISA. Gonna tell it, introduce it separately, because for branch, our PC is a 32-bit for each address. So in the official ones, the PC will jump 4 for every instruction, but in ours, it just jumps 1. So here we do not have the times 4. We just give the target PC one as current instruction PC plus 2. And for the official ones, we're going to add 8, and these PCs, because these PCs are by 4, by times 4. Yeah, it's pretty much the only difference here. We got offsets equals to 1/4 of the official ISAs. And yeah, another thing is the LDR. Because LDR, we're going to separately treat the LDR with a mark, and here we just using the RN. For RN, we use R8 because R8 is essentially never used. You can treat it as a 0, but there isn't an official 0 for ARM38. Just use R8 for now. If in the future we got something else over here, maybe we need to do some manipulation, like store it to somewhere else and store it back for the word. But for now, we can just use R8. And the word block, we put it at 128 just as a random number, like the midpoints of our data mem, so it doesn't go like to the top of the stack, more like to the bottom in case it can be used. And all the word will be stored during the ones and can be accessed. Yeah, that's another point over here, because you can see LDR is being essentially replaced by MOVR3 128. I'm gonna write 128 into it. Oh, sorry about that. That's actually been done in advance, I think. Is it here? Oh yeah, I'm so sorry. It's done by the preprocessor because yeah, I got it wrong. Because it should be the index rather than the data at 128. Because yeah, in the preprocessor we already replaced it with MOV. Yeah, that's the right move. So this is history code. It's not correct. Doesn't do anything. Yeah. Yeah. So you gotta write the address. So it's being replaced with MOV already by the preprocessor. The LDR with mark. Okay, that's pretty much it. Let's try to run it and let's see the output. So first we have to do the preprocess part with our bubble s with all the comments removed and pushing the pop removed. All the others are exactly the same as was generated by the C compiler. And so we have the preprocess s. It's right here with the vector treated as pseudo instruction and replaced with a bunch of other instructions. And the word zone has been replaced with MOV. And we do on the compiler. That's the debug information. And it's got a debug output, just like this, and binary code. Binary code, that's what we have for, yeah, this is binary code. It's just going to be used in our processor. So this part is the introduction to the ISA and our compiler. And the rest of the part should be introduced by our teammates. And thanks. That's all.